All right, so we're in 4.2, looking at question number 4. And, all right, so how do we, I already have an answer there for you, but how did I get that answer? How do we do these kind of things? Well, basically, what they say is, notice these keywords. Use the first and the last data point. So I need to do roll. I'll do it in a second when I get you working on one. So there's the first, there's the last, skip all that stuff, in other words. Does that make sense? Whenever they say first and last data points, we do exactly that. The first one in the table, the last one in the table, nothing in between. Okay, so what do we do now with this? So notice what they're saying here. T equals 0 is 1970. So that means this is T equals 0. So then, bless you, what is 1997? If 70 is 0, what's 1997 going to be? You just got to take 1997, subtract 1970, and you get 27. 27 years later. How are we doing? Am I communicating to you? So I'm taking this right here, what they said. They said, hey, use T0 for the year 1970. So I said, okay. 1970 is going to be T0. And that means that, and then if I subtract 1997, how many years later is 1997? Well, that's 27 years later. So that's T equals 27. So in other words, they don't want me to use the actual year for my variable. That's just too big of a number, 1,000 something. They want me to just start at 0 for 1970. Okay, so what does that mean I'm going to do? They want a formula for the death rate. Here's the formula. Remember how we talked about that? Y equals Y0 B to the T. We're using that same formula on that. Quiet up there. All right, so what does the Y sub 0 mean? What is this little part? When it starts out at 0. Right, that's at the start. Remember, the sub 0 means at time 0. So whenever they give any letter with a sub 0, that means the start. The Y means Y at time equal to 0. That's what that little 0 is. Y at time equal to 0. So what is the Y, and what is the Y on this? It's death rate. We're talking about death rate. These are the T's, and these are the Y's in the table. Does that make sense what I'm saying? So these are the T's in this way. So at time 0, what's the Y? 252.9. So far, so good? So that's always what the Y sub 0 is. It's the initial starting time 0 value of whatever you're calculating. In this case, we're calculating death rate. We're basically showing how heart disease, the death rates are going down because of improved medical science over the years. Okay, so we got that. Now, we have to find the B. Okay, with me on this so far? How do you find the B? These are kind of the same every time. What do we do to find the B? We've got to plug in this information. We've got to plug in T is 27 when Y is 133.5. Just like T was 0 when Y was 252.9. Do you see how what they're giving us in the table is a couple of XY points, basically? It's TY instead of XY, but it's the same thing. That's what they're going to do on these problems, is give you a couple of XY points. So the first one was 0, 252.9. That gave me my Y sub 0. The next one is 27, and the Y that goes with that is 133.5. So if we just plug those in, if I plug in Y over here, 133.5, and I plug in for the T, right there, then I can solve that equation for B. Are you tracking with me? Now we've only got one letter left. Now we can solve for B. All right, let's do it. So coming up here, we got 133.5 is 252.9 B to the 27. All right, so I want to solve that equation for you. Now, that's easier said than done. Do you remember how to solve these weird little equations? How do we solve there for b? What am I going to do? Yeah, first we got to divide by that 252.9. We good there? So first, b said I won't be alone. So first I'm going to divide by 252.9. Boom. Let's see if that's a nice number or if it's not a nice number. Remember, if it's not a nice number, I just leave it. Yeah, it's ugly. So I'm just going to leave it. All right, so we get this 133.5 over 252.9 equals b to the 27. Good so far? Now, how do I make that into regular b? How do I get rid of that 27 power?
Do I have to log it again?
No, you know what? And you know that log thing I showed you last time? That was fine and everything, but there's an easier way. We're going to do those with graphing calculator. That's easier than doing the log thing. But anyway, yeah, how do you get rid of that 27? Not a log thing. 1/27th power. Because basically, think with me for a second. You want to make that regular b, don't you? Which means b to the 1, doesn't it? How do you make that 27 into 1? You do both sides to the 1/27. Because you got to do the same thing to both sides. You always got to keep the balance. And that'll cancel it, and it'll just be regular b, or b to the 1, same thing. Does that make sense? Whenever you have a power you want to get rid of, you raise it to the 1 over that power. And it cancels it. Which is the same thing as a root, if you know, 27th root. That's the same thing. So now, can you type that into your graphing calculator and get a value on that? So let's type that in. So when you type it in, let me write how that works. It's 133.5 divided by 252.9. You got to put parentheses, remember? It's just a good practice to put parentheses around pretty much everything. Can you all see that? So I did 133 divided by 252.9 to the power of 1 divided by 27. In parentheses. 1 over 27 is in parentheses. And 133.5 divided by 252.9 is in parentheses. I'm getting, what am I getting? 0.9766. 0.9766. I don't know how many places. Oh, yeah, we're supposed to use 6 places till the end, huh? So I'll throw on a 1.5. Y'all getting that? 0.976615? Is that okay? Want to bring those graphing calculators with you to class. Hey, did y'all get one? Because there is a couple more available at the down the hall in the math office. When is that? 4 p.m. Yes, that'll be after our class on Thursday. So did everybody get a graphing calculator? So the library might still have them. I don't know. And if they're out, then just down the hall over in Science 1, just first door over there. At 4 o'clock on Thursday, Miss Carol Curtis will be giving out a few more, but there'll probably be a big line that starts about an hour before, or half an hour before, 3:30. So anyway, don't want you to have to pay for that. Okay, so let's keep going. So we get that. So that we're still not done with this problem. We got our B. We have one more step to go. Is everybody okay? These are hard. I know this is like one of the hardest things. So I want to make this clear. Anything I can answer so far? Is that good? Okay, so let me use that B. Now that we have that B, so we're back to the equation. It's y equals y0 b to the t, right? Now I know y0. This is y0. It has been all along. 252.9. Now I know the B. The B is the 0.976615 to the t. Are you good? So let me go back. What did I just do? I took that B that we found and I put it right here in its place in the formula. You guys okay? Now we're ready to answer the final question. They ask us, they say, the death rate in 1996. Find the death rate in 1996. How do I find the death rate in 1996? See how the years, they're giving me a T, aren't they? Up here at 1996, they're giving me a T. Good job. Exactly, yeah, because remember they said time 0 is 1970, exactly right. So 96 is how many years after 1970? 26 years after, huh? You take 1996, subtract 1970, you get 26 years later. Yeah, so the time of everything in this problem is always relative to 1970. 1970 is the start of this problem. So if they're asking me about 96, I go, well, that's 26 years later. So you're basically saying, take T is 26 and plug it in right there. That's what they're saying. So it was going to be 252.9 times 0.976615 to the 26th power. So I'm going to do that. I did it. I got 136.6966, which rounds to 137. The death rate will be about 137. How we doing? So we're done with that problem. That's a hard one. This is a pretty tough problem. This is one of the toughest ones in the class. These kind. They don't get a lot worse than this. Questions I can answer. It's a pretty sophisticated exponential question. Let's go back to it again. So what they're always going to do on these is they're going to give you two xy points. Time 0, y value, time 27, y value. You always use the equation when they say, exponential, use the y0 b to the t. Put in the y0, and then put in the second points, t and y, and solve for b. Once you get b, put that back in, and then answer the final question. Do you see how it's in two phases, kind of? It's kind of like phase 1 is get B, if that helps kind of break it down. Phase 1 is get B, and then phase 2 is use B to get the answer to the problem. See how these are in two phases? Phase 1 is all this. You plug in information and you get your hands on B. So phase 1 is all about using the equation to find B. Then after you've got it, then you go into phase 2 and you put in that B and get your final answer to the question. Shall we try another one? This way to do that problem. Whoops, what was? All right, yeah, let's try number 3 again. It's very similar, so that we start off here with those two and those two, because they say first and last. So forget about all the ones in the middle. Same kind of thing. Same formula. Y equals y0 b to the t. So just do phase 1. Phase 1's the same. We did that right. That's all the same. Same as what we just did. That's all good. What I want to help you with is I want to give you an easier way to do phase 2 using your graphing calculator rather than the log thing. We don't have to do that. Although that was fine. If you understood that, great. You can do that. But I'll give you an easier way. So go ahead and do phase 1. And what's phase 1? Find B. Phase 1 is all about getting your hands on the B, right? And by plugging in the first data point and the last data point. See what they're saying about time 0 is 1983, so this is time 0 again. This is time 0 right here, 1983. And so then 1995, what time is that? Yeah, 12, huh? It's 12 years later. That's time 12. Good, see what we're going to plug in there? So plug in, so 1.06 is your y0, isn't it? Because that's y at time 0. Again, the top, the bottom is the y values, the top is the time value, same thing. Plug that in again, put in your y0, and then plug in that other point and solve for b. So y0 is It's 1.06 b to the t. Good so far? See how this is always y0 right here, isn't it? It's the y value that is next to time 0. Good so far? Now plug in the last data point. Time 12, y 0.50. Plug that in, and you can find b with your fancy graphing calculator. Really encourage you to bring whatever calculator you're going to use on the test week after next. Bring that with you so you get used to doing the things on the calculator. That's a lot of the battle in here, is learning to use the calculator well. We'll do some fancy things on it. So bring that with you. All right, so what do we got? So I'm going to plug in y 0.5, boom, t 12, boom. So y is 0.50, and the t is 12. Everybody see what I did there? See how that's kind of the same thing every time? This is exactly like what we just did on problem number 4, kind of going backwards. Solve for b. How do I solve for b? What's my first step? Divide by the 1.06. Boom. So b to the 12 is 0.5 or 1.06. And now, how do you make that like into regular b? How do you get rid of that 12? Yeah, the 112 thing. Getting the hang of that? Just, when you want to get rid of a power, do the 1 over that power. It's gone. Regular b. And then whatever that number is. So make sure when you type it in, you do it with parentheses, right? To the power 1 divided by 12. Right? Everybody with me on that? You got to put parentheses around the base and the power. You're telling the calculator that the base is all there together in the base, and the power is all there together in the power. Otherwise, it will just do something weird. So get your b. I'm getting the b to be 0.939, 302. Six decimal places, like they said right here, 6 decimal. 0.939, 302. We all good? Yeah. So that's phase 1. Phase 1 is always find b. We're almost done, that means. That's the major piece of the work, is getting the b. So we got our b. Now I want to show you an easier way to do part 2. So what do we always do with that b? We plug it in, so let's go do that. So we're doing part 2 now. Our equation y is y0 b to the t, and the y0 is still right here, 1.06. The b is the 0.939, 302 to the t. We good to there? And now what they're asking us for is they're saying 40 cents. When is the purchasing power going to become 40 cents? So that's always, phase 1 is you get b. All these problems. Phase 1, you get your b. Phase 2, you use b to answer the question. You always use b. So I put in the b, I get my formula. There's my formula. Now I'm going to answer their final question. How do I do it? Well, they're giving me 40 cents. Here's the answer is 1998, but pretend we don't know that yet. 40 cents. They're giving me 40 cents. What do I do with the 40 cents? That's going to plug in to either y or t. Do you see how we finish these out? We plug in. Use b, answer question by plugging in. So we're going to plug in. Now, where does the 40 cents go? Does it go there or does it go to t? Yeah, it's not time. Time's what we're looking for. So that's tricky. They want me to put the 40 cents over here, don't they? No, that's not easy. And then I got to find t. How do you find t? Now, last time I had you do logs, and if you understood that and you like that, great. That's fine. There's another way that may be easier for you. Let me show you. I'm going to do it with the graphing calculator, but let me let you know how do you know you're supposed to do this. When the letter is in power, is in the power zone. That's what we have. See how t is up in the power zone? That's different than just having powers. Let me go back. See how right here we had a 12? That's not a letter. We had a number up in the power zone. So that's not a problem. You got a number, just do 1 over that number. Gonzo. No problem. You guys see the difference? Yeah. If you just have a number up there in the power zone, that's not a big problem. Just do 1 over that number, do it to both sides, and it's gonzo. But if you have a letter, what are you going to do, 1 over t? If you do that, it's going to be over here. What am I going to do with the 1 over t over there? It's going to totally mess me up. You can't do that with a letter. Well, what do? When you have a letter in the power zone, y1 is left side, y2 is right side. I'm going to say graphing calculator. Use your graphing calculator. Now, you could do logs. That log thing I showed you is the advanced math way of doing it. If you like that better, some of you probably will, great, feel free to do that. But I'm going to try to do it on the graphing calculator. That might be easier for some. Y1, let Y1 be the left side. So I'm going to put Y1 the left side. I'm going to put Y2 the right side. I'll show you how to do that in your graphing calculator. Y2 is the right side. Kind of went over the 1 there. Y2 is the right side. And graph it on your calculator and then hit second calc, which is above the trace key. And then choose intersect and hit enter 3 times. Enter, enter, enter. So that's basically the steps. I'm going to show it on the graphing calculator. If you have it, you can follow me along as we go through that. I'll go ahead and copy that down, though, or maybe I'll flash back to it also. So I'm going to go to the graphing calculator now. Maybe. Hello, graphing calculator. Oh, it's not that. I should turn on the Elmo. That's always a helpful step. I struggle with some technology. All right. Boom. Boy, that's weird looking. What is it doing with that? That's not helping. What? What did that do? It's in some kind of weird mode. It just looks terrible. What is that? Why is it doing that? I don't see anything. Anybody know? Why it's doing that? Is it because of the lights? Maybe it struggles with the light. I've never seen it do that before. Maybe it is, but I never had the lights off before. Oh yeah, boy, it doesn't like that lack of light thing. All right, you're right, thanks. So anyway, so there it is. So let's go through that. So here, how did I get here? I hit this Y button up here. See this Y in the upper left-hand corner? So I'm showing the steps for the TI. That's what they're giving away in the library and at the and Thursday down the hall. So the TI. If you have a Casio, those are great also. I'm glad to help you with that, office hours or something. But I'm assuming most of you have the free TIs that they're giving away in the library. So hit Y, and there's Y1. So Y1's going to be the left side, which is just 0.40. Hit enter. And Y2 is going to be the right side, which is 1.06, parentheses, 0.939302, parentheses. So when you set up your viewing window, X min is the left side, X max is the right, Y min is the bottom, and Y max is the top. You're basically saying how far left and right, how far up and down for my viewing window. Well, we just saw when I did second table, we just saw X and then Y1 and Y2. All the Y1s were 0.4. And the y2s were around 0.9 or 1.0, weren't they? So that means I should be looking for y values that are like around 1, between 0 and 1. So I should make my x min, or y, this is y, I should make this go from like 0 to 2. Because all the values are going to, here's 1, 0, 1, 2. All the values are going to be 0.4. They're going to be about right here at 0.4. Some of them are going to be up here at 0.9 height. Is that making sense? I should make my y go from 0 to 2. And the x, I don't know what to with the x. Maybe 0. I usually just do 0 to 10. So I'm going to make my x min 0, my x max 10, my y min and max 0 and 2. So let's do that. So getting back. You guys got that copied down? So getting back to the graphing calculator. So I changed this to 30. And the graph, wherever it was, it came down and it hit somewhere. Now how do I find that intersection point? That's what I'm trying to find. Why? Why am I trying to find the intersection? Where'd that come from? When did we start that? Well, I'm trying to find when y1 equals, right? I'm trying to solve this equation. Is this easier than logs? I think once you get the hang of it, it is. I'm giving kind of worst case scenario here. So when the left side equals the right side, left side equals the right side. So that's where they intersect, right? When y1 equals y2. So I'm trying to find that. How do you do it? Well, it's these steps right here that I told you. Y1 is left, Y2 is right. Graph it. Second calc, intersect, enter, enter, enter. So now I hit second calc on your calculator. So here's what you actually type. Second, step 1, hit second calc, and then choose intersect. And then once you got that, just hit enter 3 times. Enter, enter, enter. So second calc, intersect, enter, enter, enter. Let's go back to it. So you see calc, it's right here above the trace key. So second calc. Go down to intersect. See the intersect routine? Enter. And then just go enter, enter, enter. Boom. It found it. There's the intersection. It's x is 15.56, y is 0.4. Now, what did we want? Remember, the x is the t. Yeah.
After this, can you go over the log?
Sure. All right. So 15.5. We will have to do things with the graphing calculator later, though. Things that logs won't do. So make sure you are getting this down. 15.56. So there's our intersection. That's the answer to the question. So if we go back and we say, okay, it came out 15.56. That's the answer. What was the question? It was, I'm getting lost here. It was, that's after 1983, isn't it? I forgot what we were even doing. That was after 1983 was the start of that problem. So I got to add that to 1983. That will be what? 1998.56. So it's in the year 98. That 0.5 means like halfway through the year. It's like in June of 1998. So the answer is 1998. They want to know in what year. You don't round that to 1999. It's closer to 99, but it's still in the year 98. It's like July maybe. So yeah, it's closer to 99, but they didn't ask which year is it closest to. They said which year is it in. It's in 1998. That's why in the year 98. Does that make sense? Because remember, it started at 83, so I had to add that answer to 1983. That wasn't easy. The logs aren't easy either. There's no easy way to answer that question. I can show the log thing again real quick. So what was the question? It was 0.4 equals 0.4 equals 1.06, 0.9, 39302 to the t. So t in power, use graphing, calculator, or logs. So the log way would be just put a log on both sides. So log on both sides of the equation. Oh wait, no, I forgot, huh? First you gotta divide. You can't do the logs until you get the base alone. So yeah, so the log way, step 1, get base alone. You know what I mean by base? This is the base. The base is, a base, like this is the base of the table. means it's got something on it. A base is something that has something on it. So this is the base. It has the t power on it, right? That means you got to get rid of that 1.06 because he's not the base. So divide by that. So get the base. Then 0.9. The base is the 0.939302 thing. So get the base. Get base alone. Step 2. Log both sides. So now you bring the log in on both sides, log on this side, log on that side. And then step 3, the t comes down to the front. So the t will go down to the front. That's the great thing. It gets that down to the front. Like that. The other side hasn't changed. Like that. And then the last step. Now that the t's down, out of power, it's cake. The whole problem was t was in power, and we didn't know how to deal with that. But now that t is down on the base level, it's cake. Just divide. It's just t times that log stuff, right? So just divide by that whole log expression. Boom. Type all this into your calculator, you get the same answer we got, which was what? 15.56. So that's how to do it with logs or with graphing calculator. Not sure which one you like better. There we go. Is that good? Questions on that? All right, we better move on. That was a lot of time on those. Those are hard, but we got other fish to fry. It's gonna be on YouTube later. Finish it. These are hard. All right, so here we go. It's been found that a worker new to the operation of certain tasks, semi-line will produce items, blah, 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 that formula. How many items will be produced on the first day, and what is the maximum number of items according to the function the worker can produce? Okay, how many items on the first day? So I've already got an answer there, but how do we find it? First day. Well, how do you find first day? We'll see what day is. T is the day number. See, I found it right here. T, it's day T. So t is the day number. So if it's the first day, they're saying take t equals 1 and put it into that formula. That's what they're saying. So the formula, P equals 23 minus 23e to the minus 0.2t. I can hardly see that formula. E to the minus 0.2. I bet you can hardly see it too. So there it is. There's the formula. There's the formula. And when they say how many, that's how much P produces. How many items does the person produce on the first day? Oh, thank you, Joel. On the first day. How many items do they produce on the first day? Take that 1 and pop it in right there. That's how we got that answer to the first question. So 23 minus 23, e to the minus 0.2 times 1. Can you type that into your calculator? So it'd be 23 minus 23. The E button is above natural log. You got to hit second ln, and that'll put an E to the power. And you got to put parentheses, negative 0.2, and hit equals. So type that into your calculator. And remember, the calculator gets really upset if you confuse a negative with a subtraction. Negative is in the parentheses at the bottom. So I'm getting, when I did that, I got 4.169. And so that's why it was rounded to 4 items. Is that okay for the first part? Again. So just plug a 1 into that formula, but make sure you can do this kind of stuff on your calculator. On that. Okay, and then the second part, the maximum. Maximum. How are we going to find maximum? Graphing calculator. This is where we got to do our graphing calculator again. So in other words, so whenever they ask max or min graphing calculator, you got to use your graphing calculator. Put in y1, this whole 23 minus 23 e to the power. Well, I'm running out of room here. Let me go to a fresh screen. So for max min, graphing calculator. Y1 is 23 minus 23 e to the power minus 0.2x. You got to put in that x. That's the t. And then you've got to graph it. So step 1, put in y1. Step 2, graph it and use the window to see the max. We're trying to find the maximum. Step 3, use the window to see the max. Step 3, hit second calc. So I'll send you a YouTube also, because this is not being captured on the, these steps are, but whenever I go to the graphing calculator, that's not on YouTube. I'll send you a YouTube with finding maxes and mins. So hit second calc and then choose max. Hit second calc max. Let's do. So it's just 23. It's just that number. The max is just that number in the front there. That is the max on that one. That's what the graphing calculator shows with those steps. Yeah, so forget about this second calc max. Forget about that. I didn't do that. I just graphed it and moved the cursor around. Good enough. All right, here we go again. All right, so they give me this function. So 73.6 over 1 plus 16, 0.8428. 8428 to the x power. And they want the number squared to be 47 million. That means that's the other side. The 47 goes on the other side. So I have to solve that equation. You're going to definitely need graphing calculator here. So I'm going to make this side y1, this side y2, graph, and do the second calc intersect thing. Graph, second calc, intersect, enter. So when you want to solve an equation, it's very difficult like that. I mean, that's hard to solve for that x and that weird position it's in. Let the left side be y1. Let the right side be y2. Type them into your graphing calculator. Graph it. Hit second calc, intersect, enter. So give that a try. Now that y2 is not easy to type in, is it? Let me write out some things to help. Remember what you're supposed to do with the denominator? What are you supposed to do? Parenthesize that whole denominator. So it's going to become 73, so y2 will be 73.6 divided by parentheses 1 plus 16, another parentheses, times 0.8428 to the power of x, parenthesis. See all that? And y1 is 47. So put y1 in as 47. Put y2 in as that whole big thing there. Hit graph. Probably see nothing. Check your table. Adjust your window. So I put in y1 and y2. I hit graph. And there's what I got. I haven't adjusted my window yet. Now, is that a good window? How do you figure out what the right window is? Yeah, we're looking for an intersection. So what do I got to do to fix my window? What do you always do? This is a quiz question I'm hoping to hear in chorus, in uniform answer. At least I hope it's in your minds for sure. What do you do? Do you know what to do? This is the sticking point for people. Do you know what to do when the window's just not right? Where do you go? Table. Okay, let that sink in. That's really important. Table. Table tells you where it is. It's like a search party. Like, where are you, graph? I'm supposed to be seeing a second graph. They're supposed to be hitting. Where's the other one? Right? I got one part of one of them, but where's the other one? What's the search party? Table. Right up here. Second table. That tells you where the table values are. Oh, he's at 47, and the other one's in the 60s. Well, that's not crazy or anything. What's my window? So it looks like my Y values need to cover 40s and 60s, right? See how the table tells me where the Y values are? So go back to window now. Oh, what's the problem with my Y? Remember, Y values, let's go back to table. Y values need to be 40s and 60s. See all these? 40s and 60s? Where's my Y? It's only going up to 30. No wonder I'm not seeing anything in the 40s or 60s. You see that? So I gotta go high enough up that it covers things in the 40s and 60s. So I gotta go up to 80 or 70 or 90 or 100, whatever. What about X? How do you know X? I don't know. Just leave it 0 to 30. If that's not good enough, make it bigger or smaller. X is pretty simple. The Y comes from the table. So I'm at 0, 30, 0, 80 right now. Graph. See what we got. I just need them to hit. Beautiful. 0, 30, 0, 80, they hit. I just need to find that intersection. Because that's where the left side equals the right side. That's the solution to the equation. Where they hit, they're equal. Right? So how do you find, once you got it on the screen, you just go to second calc, which is above trace, second calc, go down to intersect, and hit enter, enter, enter. Boom. There it is. 19.5399. There's where they intersect. So x equals 19 point, what was it? 19.5399. Want me to round? What? Oh, 0 is 1970. They're doing that same thing where you start off. So I got to add 1970 to this. So this is basically 20. Or no, this is, you don't, okay, first of all, I got to add the 1970, right? Because it all started in 1970. It's that many years after. So add 1970. And you get 1989.5399. That's in the year 1989 again, isn't it? It's like July because it's 0.53. So it's in the year. It's far down. You don't round it up. It's not in 99. It's closer to 99. Or 90. It's closer to 1990, but it's in the year 89 still. There we go. We good? Been doing a lot of graphing calculator stuff, huh? So I found my answer from the graphing calculator, 19.53. I added 1970 because that's when this started. Time is 0 in 1970. Got 1989.53. Leave the answer at 1989 because it's in the year 89. It's just late in that year. I think we might finish this section.